For today's topic overview, we have our office hours today will be focusing on the CDR Databricks environment, file management, and data access. So our big topics of the day are going to be CDR Databricks environment, common file management functions, key features of distributed environments, and then best data practices for org sharing resources. And our presenter today is going to be Dan Anderson. He is a SAS programmer on the QDAS team. So we are going, or I should say in the QDAS, team. I'm sorry, Dan. So I'm going to pass things over to him now, and he's going to give us more information on himself and then what he'll be presenting. So I'm going to turn things over now. And Dan, whenever you're ready for me to stop sharing, just let me know.
Yeah, so quick introduction. My name is Dan Anderson. I'm a SAS programmer. I've been a statistical programmer and systems engineer for about 14 years now. And I've worked in fields ranging from biomedical assay development to manufacturing and sales data reporting, and even working on calculating the US Census data for the last census. I've been with QDAS now for just over a year. Some basic background: I've been doing SAS for the majority of my time. It's been about 10 plus years on SAS. In the middle, I've been doing Python and R for about 3 to 5 years, periodically as needed. And I mention those to you just because I feel your pain. I love, the work that I do, but I've also been working in SAS for a long time. And so I understand what you're going through. And so like my primary task right now as a SAS programmer is to help you migrate your code out of SAS Viya. And unfortunately, there's going to be some training and upskilling that's going to be required to be able to do that. And that's what these presentations and particularly today's topic is really going to try to help you guys out with. So if you want to go ahead and switch over, Julia. As a reminder, my colleagues, Derek and Colton, will be answering questions in the chats as they come up. And then we'll call out a few as there's Q&A time. There is a lot of content, and depending on how we're doing on time, I may or may not be able to walk through all the code examples with you, but this is a Databricks notebook. The URL is actually, this whole thing has already been shared with you. You're all able to view this and access it. I'll share the relative path at the end so that you guys can find it. I just would prefer we focus on what's being presented right now as a way to be not too distracted. So my approach to this today is going to be about the CMS, the Central Data Repository Databricks environment, specifically focusing on file management and data access. So as an introduction, why is this something that you need to know? We're going to get into a little bit, not too deep, trying to keep it still somewhat high level, but it is going to be some systems type diagrams and things like that. And you're like, why do I need to know this? Well, the reality is that your data sources are all external to your compute system, and they always have been. In SAS Viya, though, the compute resource was pretty static. We spun it up once, and we were able to manage the data connections on your behalf. In Databricks, each org has been assigned their own compute system, compute cluster, and they're transient by nature. So after 60 minutes of inactivity, it will be spun down. And when you spin it back up, you're going to have to, manage your connections. So you'll need to know how to connect your compute system with your external storage spaces, and particularly based on your use cases. Another thing to understand is that SAS Viya and Databricks use fundamentally different approaches to storing, retrieving, and processing your data.
Hey, Dan, are you sharing your screen? You're supposed to share your screen.
Oh, I'm sorry.
Yeah, sorry. That's okay.
Oh, wow.
I didn't want to interrupt your role, and I felt like maybe it wasn't time to share it yet, so I was just going to wait. But I'm glad someone else. I wasn't sure either.
I apologize. There we go. Oh, stream on. Here we go. This is what you should have been seeing. All right, everyone seeing this screen now?
Yep, we see it now.
All right, perfect.
I'll drop the link in the chat for everybody so that they can get to this notebook in case they can't find it.
I've got it published at the end as well. So that way, like, I kind of don't want, ideally, don't want you to be distracted with everything else that's in there, but you'll have it as soon as possible. But anyways, you can drop the link if you want to as well. So, right. So why do I need to learn this? And this is really what I was talking about, is that, point 2 is that they're fundamentally different approaches to how they store, retrieve, and process your data. And unfortunately, you're going to need to understand these differences in order to modernize your code and execute them within the CDR Databricks environment. At a high level, SAS Viya was essentially a single compute source with a massive amount of, of processing capabilities, but then that was also shared amongst every org. And it wasn't very efficient in the way that it was storing its data and working with large data. Databricks uses a distributed computing technique, which is really focused on faster reading of data and processing of that data. So my goal for everybody at the end of this is that you should be able to understand the compute and file management systems within your Databricks environment. You will know where the external data, such as the CDR and your org workbench, is stored and how to connect your compute clusters to both sources. You'll understand how and where your data permissions are being enforced. You should understand some basics of distributed Databricks systems. And then you'll know how to import and use data files from the Databricks file system and utilize the driver node. My assumptions I've got, are just a couple, assuming that you know how to identify the path of your S3 workbench and you know what the S3 workbench is, have a general understanding of file permissions. So when we talk about data files and such, we're talking about like read, write, execute. When we're talking about kind of SQL tables or Hive tables, we're talking about kind of create, alter, drop, select. And then the org roles that are applied for your compute clusters. So your compute clusters, we discussed it last week, and when those are posted, you'll have a chance to also see that where they implement your org roles. And that carries forward like permissions for the CDR and your S3 buckets. There's a general understanding that your S3 paths, your buckets have permissions that are applied and enforced, and also an understanding of the CDR catalog, kind of the Hive tables that we've used in the past. I also wanted to call out the fact that we typically call everything by org. And of course, that can be a little confusing because you can have multiple companies that are part of the same org, or a single company may have multiple orgs. Conceptually, the orgs are generally more aligned with the projects that you're assigned, and sometimes task orders, implement new DUAs and things like that. So that's kind of how our granularity is on the org level, or definition of the org level. And then in Databricks, I expect that you'd be able to create your own new notebook within a Databricks workspace, set the permissions as needed, and then connect your notebook to your org compute cluster, understanding the difference between your R only and then the standard compute clusters. My topic outline, as we discussed, pointed out earlier, we're first going to talk about the CDR Databricks environment, kind of at a systems level. And then we're going to talk about some common file management functions. Then we'll go into some key features of distributed environments, and finally do some best practice, some best data practices, particularly for org shared resources. And then I have a couple additional resources at the end. How are we doing? Any questions yet, Derek? Hopefully nothing too major yet.
You're good.
All right, cool. All right. So the CDR Databricks environment. This is a little bit of a daunting diagram here, but I'll try to guide you through it as easily as possible, painlessly as possible here. So what I want you to understand is that the native Databricks environment has effectively no external data connections. If we think about Databricks by itself, our environment has the compute clusters for every organization. They may be, turned on or off, but everybody has, their compute clusters, and then we have a Databricks file system. The Databricks file system has a section that's basically coined as root. And then there's add-ons that can be mounted. The root I want to point out is in red because this Databricks file system is accessible to anybody who's using any compute cluster within your Databricks environment. So if you were to try to put data in this root section of the Databricks file system, then any other org could access that same data and it wouldn't be secure. At least within, it would be retained within our data environment, but it would be exposed to everybody else who has permissions to be a user in our system. Also, just pointing out again that we've got multiple connections going on at all times. Everybody, your compute cluster is primarily, we'll go into this a little bit more, but you've got your driver node and your worker nodes. The worker nodes are typically in the hatched dots because they come on and come off as needed. And yeah, so I've got root in red, just means stop, don't do anything in there. When we do anything with the Databricks file system, we're actually going to do something with a mounted section, and that's going to be in green because whatever we mount has additional security stuff that we're going to address. So this is your native Databricks environment. This is what spins up when you spin up your compute cluster. All you're doing is connecting to the Databricks file system. And the driver's connecting to its worker nodes. So, what about the CDR? Right, we're familiar with the CDR, the Hive CDR. Let me go this way. Hive tables. So the CDR is actually managed for all groups by the QDAS team, and these connections to the CDR catalog are automatically spun up on your compute cluster. If you're on the R only compute cluster, that hasn't been built out yet. That specific connection to the CDR. It's something we're working on, but it doesn't exist as of yet. So when they do have this connection to the CDR catalog, I want to point out that the CDR catalog itself is connected to not only your driver node, it's also connected to the worker nodes. So the workers will so the driver node basically orchestrates everything that needs to happen. And it will say, all right, worker node 1, you're going to do this work. 2, you're going to do this. 3, you're going to do this. And they're going to know what data they need to be accessing. And so they have direct access to the CDR to pull the data they need to be able to do the work they need to be doing. Note also that, so for the CMS schemas, based on your DUA, you'll have basically read-only permissions. So pretty much all the schemas that are within the CDR catalog are going to be select-only, or effectively read-only. The org schema, you have your one org schema where you have full permissions. You can create, select, drop, alter. And so it's up to each org to try to figure out the best way of managing that space. But there are some good practices as well that we will be addressing later on in this conversation. So that's one data source that we connect to. What about another? Well, another data source is your workbench. My apologies as my mouse tries to figure this out. There we go. So your workbench is basically just an S3 bucket. We've hopefully identified that by now. And each S3 bucket has their own policies, and permissions are enforced by those policies. And those, policies and permissions are managed by QDAS. But ultimately, you have this S3 bucket, and you have your objects in there that you want to be able to compute. something or pull them in and do something with them. So you have two options. If it's something that's going to just need to be performed on the single node, on a single node on the driver node, and we'll get into some of those examples, then you can actually just copy a file directly from your S3 workbench to the driver node. However, if we're doing something more distributed like, and you want your worker nodes to be able to connect to it as well, then you're going to want to mount it into the Databricks file system. So we're going to talk about workbench connections as well and mounting. But at the end of the day, this is kind of a complete overview of what you're working with. Every time you load up your notebook, the compute environment beneath it all. You have your driver node, you have your worker nodes. Depending upon the amount of work that's going on at the time, you may have a bunch of worker nodes or very few. The driver node is always connected to the Databricks file system. Your worker nodes are always connected to the Databricks file system. If you're on your org's compute cluster, not the R only one, but if you're on the one that's just usually called compute cluster, your CDR permissions and connection to the CDR is automatically established to the driver node as well as the worker nodes. And then the org workbench connection is up to you and your use case, but you can either do a direct copy to the driver node from your S3, or you can mount it to the Databricks file system and access it using the Databricks file system. And then I've got the ... dots here, and you may have seen it earlier. It's just to, extract and point out that, everybody else's compute cluster is doing the same thing. Are there any questions about this environment at this time?
There's no questions in the chat.
Yeah, perfect. I think that seeing this and understanding where the connections are really helps me to understand what I'm trying to do and why things aren't working and troubleshooting things. And so I really wanted to be able to present this for this group. So now, some common file management functions. Let me get this back to a reasonable size. Okay. Oh, geez. All right. So anything related to the Databricks file system and working with file management within the Databricks environment has this kind of global function called dbutils. But it's a dbutils function, and dbutils.fs. And you can, if you type in .help, this is the same syntax in Python as it is in R. I do have some hyperlinks throughout here, so you can go look at the documentation. But you'll see that, this guy's got two types of work. It does file systems utilities, such as copying, listing directories, making a directory, moving files, removing files, outputs, and heads, just, so these will describe everything that it does there. And it also has mount functionality. So this controls the mounting of your S3 buckets and refreshing them, unmounting them, mounting them, things like that. If you have a question about any particular function, like, the listings, you can just type it in like this is the syntax, and it will output everything for you. It does output Databricks, and most of Spark in general is actually kind of written in a Java derivative called Scala. So sometimes this might be a little confusing, but you can also just kind of go up to the Databricks utilities hyperlinks and find additional resources in their documentation as needed. So just to give us a sense of how file management is performed in this, I've got a simple use case example, and the use case is going to be using content from my S3 bucket. So I've got, in this particular case, I've got 4 files that are on my org's workbench's personal folder. And I need to migrate them to the driver node of my compute cluster. So again, there are two ways I could do this. I could, very realistically just copy everything from here, from the S3 path directly onto the driver node using option 1, but that wouldn't be giving you guys as much code to copy and paste later on and exposure to the options that are out there. So we're going to go the long way around on this particular one, and we're going to do option 2, where I'm going to mount to the Databricks file system, and then from the Databricks file system, I'm going to copy it directly to my driver node. So this process, pretty straightforward. Mount the workbench to the Databricks file system, and then copy files from the mounted workbench to the destination path, to a destination path in the driver node. Some of the functions that we're going to be able to see here are going to be highlighting just the DB utils listings, display wrapper that we're going to talk about, mounting, copying, removing, and unmounting. The remove and unmount won't be immediate. I'll actually show those all the way at the end. But this is just to get a sense of what's going on here. To mount your workbench from to the Databricks file system. So my workbench is an S3 bucket. I know the path to my S3 bucket, and I decide. So for example, here in this folder of Databricks images, I've got a number of PNG files, which are actually the pictures of the diagrams that were hosted up above. And for some reason, I want to migrate these to my driver node. So here I'm just confirming that it exists in the S3 bucket. The output here, it's informative. It tells me where my path is. It tells me the file name and the size and modification time, but it's not very user-friendly. So in Databricks, you can wrap it with a display function, and it will determine a schema so that it can create a table for you. And so this is, the output. This is the exact same content, but structured in a table. And in fact, this is an interactive table, so you can sort your columns as you wish, and expand or shrink the size of everything else in here. That was just, you'll see I do tend to use this display wrapper throughout, but again, the key function that's being utilized is actually the DB utils. We're about to mount. So for mounting, I'm just showing the help. I had the help output here. I'm just collapsing it so that we can see something else that I wanted to direct your attention to. So I'm going to mount, because of the way that we manage your permissions and everything and your roles, you don't have to worry about additional credentials to mounting your S3. All you have to do is identify the path where you want a mount to occur, and then basically the alias that you want to assign to it. So for example, although my data is all the way down in this folder of Databricks images, I actually just want the mount to go to my personal folder or personal directory here. So I've got it going down to the Anderson DA. And I'm mounting it with a name, with an alias, QDAS_DAA. One thing for you to understand is that mounting, so mounts have a finite, like it's got everything, all your mounts have to be unique within all the organizations here. So if anybody else for some reason had the name of a mount as QDAS_DAA, I would not be able to do this. It would fail on me and I'd have to find a different name. For this reason, we tend to recommend that you unmount stuff as well so that other people can use that namespace, but also pick unique names, right? Don't pick test or something like that. So this should be So this will then output a true, which just means that the mount was successful. Note now that when I run I can actually just declare the alias location of the mount Q-BAA instead of listing out the full S3 path. And it's still connecting to the exact same thing. And when I run a display at that personal directory level of Anderson DA, you'll see I have what's showing as a preface of DBFS because it's mounted into the Databricks file system, and that's what I'm actually accessing. And your mount, the alias name, and then the unique names that I had in there. So I had two folders. I have a Databricks images and then an examples public. So just to confirm again, I run a display listing of the Databricks images, and I can compare this to all the way at the top where, I just ran the listing from the S3 location, and you'll see it's exactly the same content. So now I need to identify I'm going to copy this content to my driver node. So I need to identify a destination path in my driver node. To work within, all of these listing stuff, when we list it like this with no preface or anything like that, it's automatically assuming Databricks file system. So you get DBFS. The reality though is, well, I can be working with my DBFS, right? And my S3 via mount to my Databricks file system. But what do I use when I want to actually specify the compute cluster and the thing that's actually doing the work? Well, the compute cluster just goes, it's basically considered a local file structure. And so you just call with the preface of file instead of DBFS. If you do a basic listing of the file contents, basically this should be the root level of the file, the local directory. You'll see all these directories in here. If you happen to be familiar with any Unix or Linux type systems, this will be very familiar to you. Otherwise, it doesn't really matter. It's just, what the system is underneath. So let's say I want to transfer my data over. Where's the best place to transfer it to? Now, every person will have their own preference. My preference is to direct my content into a file into a directory that I'm familiar with. The TMP folder, like directory, typically for Unix systems is for temporary type things anyways. And so I just go into TMP and I created a new directory called demos week 2. And I did that with the DB utils make dirs. Of course, I'm listing here. It's an empty directory. There's nothing in the folders in that folder. I did want to point out that when I wrap the display, when I utilize the display wrapper on this, or the display function on something that returns an empty data set, it's actually just going to say can't infer a schema from an empty data set. Well, it does not mean that the directory doesn't exist. It just means that the directory is empty and it is expecting to have to create a table, and it needs file names and a few other things, and it doesn't have any of that content. So what we're going to do next is just copy files from the mounted data workbench to my destination path in the driver node. To do this, I've got some Python code in here. What I do is I create a listing. Well, I return the object of the list for that location. And then within here, anything that ends with any files that end with a PNG, I extract the file name and pass that into a list called required files. And then for each of those, I loop over and I just copy from the mounted location into my worker node. And then I have a print statement here. So that was successful. Just to verify, I can now do a listing of that same folder that was previously empty on my local file system here, and it shows you the file names, everything's in there. So I successfully copied a bunch of content that was on my S3 location in my S3 bucket and put it onto the driver node. This particular case isn't very exciting, but there is a case later on where I will show you the necessity for doing that and when that is required. I will, as a side note, just want to point out that you can use alternative languages for performing some file management on the local cluster. So on the driver node, if all you're doing is working on the driver node, you can use the Python OS. There's also something called Magic. I forget what it's called, Magic something, but I've got a link to it down below. So you can use a bash shell and just output the information from there too. Here, even with, one thing I like is on the bash shell, it shows me what my permissions were for each of these direct files in here. Any particular questions about this topic of file management? I see. Let's see here. Any difference between accessing directly from S3 versus mounting them first and then accessing the mounts? Yeah, so the primary difference, so there is one question, right, in the chat. So is there any difference between accessing files directly from an S3 path versus mounting them first and then accessing from mounts? So there's a later example where you'll see it, but at this level, it's a little difficult to demonstrate, but basically everything in your S3, if you're copying directly to your driver node, then you can only do this option 1. But option 2, if you mount to your Databricks file system, then you can do some distributed tasks where your worker nodes would actually have access to the content within your S3 bucket. So that's the primary purpose for mounting and just utilization of functionalities of Databricks file system. All right. Any other questions to discuss at this point? All right, I will keep plowing forward. I hope everyone is still awake. So the next topic that I really want to touch on, wow, it's already 2:37 or 3:37. So key features of a distributed environment. We talked about how SAS and Databricks are fundamentally distinct. There's a lot to discuss about this, and we actually have an entire topic next week dedicated to discussions of how distributed environments are different and things we need to do. But the high level answers, quick answers are 2 things. There's distributed computing, which allows a driver node to orchestrate and distribute and reconstitute smaller computational tasks amongst the worker nodes. So it chops up your work and has you run a bunch of smaller tasks, which then are actually faster than running it one time off of a big server. The second, and really a big deal about, especially with Spark data frames, is this concept of lazy evaluation. If you've never heard of lazy evaluation, it is the reason why Spark is important. Basically, your data frames, when you create a Spark data frame, it doesn't really contain data. A data frame tracks the transformations that are required to create an output, but it doesn't actually execute any of that until the output is actually required. So when you save a function, or if you're running, you just need to collect the outputs of something for feeding into the next process, something of those, if that output is required, then it will execute. Otherwise, that's why you can click, run so quickly on a cell that does something with a data frame, because it's actually not doing anything. is just tracking the transformations that will be required in the future. And then when it does execute, it's optimized based on the processes that are required. So, all right, well, we'll do this one first and then this one second. And it will also look at just saying, all right, well, these ones are never even touched, so we're not even going to bring that data in. So this is why Spark is so much faster and why people in modern big data computing use Spark data frames. With that, that's about as much information as I'm going to give you about Spark data frames today. What I did want you to notice is that basically, you have data transformation and data storage. If it's not like basically in SAS, right, or non-distributed methodologies, would it just do a create like in Python, you'd have a pandas data frame, or in R, you'd have like a data.frame or a tibble that would perform all your transformations and calculations on your driver node or on your primary system. The data storage is usually just something flat like a CSV, or you could have these, a SAS 7 BDAT file is effectively it's a flat, non-distributed table. It just has some metadata along with it, similar to like an Excel file. Doing this in a distributed fashion requires transformations pass through a Spark data frame, and your data is stored in a CDR data catalog. So all the stuff in the CDR catalog, data catalog, is stored with distributed methodologies. A quick side note here as well, a Spark data frame, we'll talk about, it's the same thing. At the end of the day, a Pi, like when you do Spark R or Spark SQL or Pandas on Spark or PySpark, they're all just building onto a Spark data frame. And ultimately, everything is still being processed as a Spark data frame. A best practice that I'm going to point out here in our first example, and I think based on time, I am going to skim through these code examples, but I will touch base on this one, is that, again, data storage is most effective. Distributed fashions of data storage are most effective in the data catalog. But again, the functionality, like the transformations, are most efficient in a Spark data frame. So rather than necessarily running a bunch of Spark SQL and creating temporary tables or something like that, we recommend that you actually create a Spark data frame, run all your transformations, and then output your final transformed data frame into a new CDR table. So for example, here, I'm reading in the public data zip codes file into a data frame. I'm doing a take 10. So this way I can just see what does my output look like? I don't need to store it. I don't care beyond that. I just need to see kind of does it look like I expect it to look like. I want you to also understand data frames are intended to be transient. They're all about transformations and logging different things. So I can reuse the same name with the same file. So I can redeclare basically in here, I'm adding for all the states. If it's a New England state, then I'm creating a new variable called New England. And I can do that where I'm creating the data frame 1, but starting with data frame 1 as well. And when I complete this, now here my output is, it's got the New England. Again, this is only just showing the top 10. But I've also preserved that amount of that data structure. So for example, if I had chosen to use a data frame 2 and set that equal to this, now I've got in my space, in my memory, I'm tracking all the transformations of data frame 1, and then a separate data frame with all of its transformations being tracked, when really they're all linear transformations and can be piped together into a single data frame. And so you're conserving cached memory, and really it's more effective to do it this way, if you can. Here I'm running a filter for just the New England states on here. So now again, I'm creating another DF1 is being updated basically with DF1 filtering for just the New England states. And I finally write it out as a save table to my org's schema. And I just gave whatever name. And so also best practice, because anything that I run from a notebook is going to be created and stored as me as the owner. If other team members want to be able to access it and work with it, they'll need to be able to have ownership permissions. So we run the alter table, changing the owner to my group with backticks. And then I just show, just as a SQL statement, just showing the select top 10 of these. And you'll see, yep, here's New England, it's all here. And because I was able to limit, again, I'm doing limits on these because I don't care about the full thing. If I did not put a limit statement in here, it would show me up to 10,000 rows, which doesn't do me any good, at least for these purposes. I will leave, just because of time, I'm going to leave use case 2 for you guys to peruse on your own. But I will say, in this particular case, this was a case where we take contents of a CSV file that are in the DBFS, and we can read it directly in without having to transfer it to the driver node. And that's because there is a read format, a Spark function for reading. And so I can just directly point it to the Databricks file system here. Likewise, I could have pointed it to a mounted S3 location, which would then be considered kind of like a directed thing, or distributed. Finally, just one quick example as well with, well, what about non-distributed data processing, right? We talked about some CSV files because Spark has the function to directly read in a single CSV location and process it in a distributed fashion. Those are one situation. Well, what about if it doesn't have its own read function? For example, what if I've got a SAS data set and I need to convert this into a Spark data frame? So one of my colleagues has created a function that utilizes another package that is available via open source. But first you have to, and I'll walk you through this process. So first we have to install this one dependency for Python. And then here's a function, but basically what it does is it takes my S3, I provide the S3 location of the file in the file name. It will copy that into my local locate, copy it with this dbutils to my driver node. Right, you'll see the file declared here. So it's going into my local driver node, and then it returns a pandas data frame. And then I automatically, in turn, convert that into a pandas Spark data frame. And then I remove the file from my local node because there's no reason to clutter that space with my data when other people could be using it as well. And it will return a PySpark data. It returns a pandas on, what is it called? Pandas on Spark data frame. That's an abstraction of a Spark data frame. So we run this. You can see it took 2 minutes to run. But I read in 4.3 million records. Then I could output, because this is a pandas on Spark data frame, it has additional functionality, so I can output, like what the head looks like, the top 5 rows. I can also run a describe statement, so I get the mean, standard deviation, min, max, all that. And that is what I wanted to share with you. Because I think it's something that we all will want to be using at some point, but also this was a case where, because Spark by itself can't read it in, we had to migrate the data from my S3 path to our Databricks, our compute node, our driver node. And then we could import it into or convert it into a Spark data frame. I'm quickly going to pass through this because I do want to talk about, I know there are questions. I do want to talk about the best practices real quickly. One thing you should be aware of is that anything in the Databricks file system is perpetual and exists for everybody, including your mounts. So your mounts will be visible to other people. They just won't have access to be able to view anything inside of the mount, because that would require connecting to the S3 location. But this also means that we can end up with kind of a cluttered DBFS space with a bunch of mounts that are basically abandoned. So best practice is to, unless your organization has decided on a permanent mount name, just be sure to unmount your S3 mounts on the Databricks file system. And then your compute clusters are shared by your org. So keep that in mind with any files that you may have to migrate from the S3 bucket and put onto your driver node. Just make sure you try to remove those right away. And so here, we're just showing some cleanup. So here again, the DB utils removing. I'm using a recursive removal of everything that I put into the demos week 2 folder that was originally put on the driver node. And you can see then that when I run the listing, it's no longer present in here. Likewise, if I run a listing of my mounts, you'll see there's a QDAS DAA. And so I unmount. It shows me as having unmounted it. And I can confirm with my listing that, yeah, QDAS DAA is no longer here. Also, if you know that you're done with some of your schema or some of your tables that you may have, Hive tables that you put into the org schema, delete those. So that's what I'm doing here. And to wrap things up, just to touch base on again, my goals for everybody was to be able to understand the compute and file management systems within your Databricks environment. So you have the driver node orchestration and the worker nodes. Your Databricks file system, again, only use mount portions for anything that's data or your S3 locations, and do not put anything in the root section folders. We're in the process of trying to lock that down so you couldn't accidentally put something in there, but that is still something you need to be aware of. You know where your external data is and how it's stored and how to connect it to your compute clusters. So the CDR catalog is auto-configured for each org's compute cluster, however, not yet for their R-only clusters. The org's S3 workbenches can be mounted and accessed on both of the clusters. Understanding data permissions and how they're enforced with the CDR catalog, that's all auto-configured as read-only for any of basically all the rest of the CDR schemas, with the exception of full permissions on your org-specific schema. And then your S3 workbenches has access enforced based on the S3 bucket rules. Understanding of the basics of distributed Databricks systems, focusing primarily on lazy execution and driver-only processing if a library is not compatible with Spark. So that's, that I didn't explain it very well, but the main reason the example with the SAS7 BDAT file had to be processed on the local server was because like I said, there wasn't like a Spark read function for that type of file. And the only option we have was this PyReadStat or something like that package, which was not built for Spark. And so when that's the case, then you have to perform all your content, and your execution has to occur on the driver node. To see additional examples of importing and use of data files and the DBFS and driver nodes.
Dan, just a heads up, we have 1 more minute.
Yeah. And that was it. I apologize. I was really trying to squeeze almost too much into this. Was really trying to keep it down to 40 minutes, and then things got exploded. But I hope that this was available, makes sense to you. If you have additional questions, you can continue to put them in the chat. If we don't get to them during the next 5 minutes, we will get to them and post them and make those answers public. And I will turn it all back to Julie. And again, thank you for your attendance. Thank you for your patience, and apologize it was such a long topic.
So I do think that we were able to get all of the questions though answered in the chat by Derek and Colton. So I've been recording those and the answers. So then that way we can get those out to everyone in case anyone else had similar questions and didn't get to see them in the chat. Dan, you're getting praised right now saying how helpful it was. So that's awesome. So we are going to do a quick 5-minute survey just to see how everyone felt about this office hour session and what we can do to improve in the future. So these questions will be anonymous. We're not collecting your name, but I did want to pull that up here now. It's only 3 questions, so please just be honest, give us feedback so we can get better.
And I think one thing for the users for everybody to understand, we are going to be repeating, based on demand, we're going to be repeating these. And so just because we presented it once doesn't mean that we're not able to still modify things and make it better the next time we go around. So please keep that in mind in your constructive criticisms.
We are a minute into our survey, so we'll give it another maybe 3-ish minutes. We can end right at 4.
Before everyone signs off, just make sure that you either reference the location for the notebook or you've taken it out of the original chat so you can review it at your leisure. But everyone has access to it. Every user of the CDR Databricks environment has access. So your colleagues and everybody should have access as well if you need to just share it with them.
Thanks, Dan. At this point, that wraps up our SAS Viya Transition Topics Office Hours. So thank you so much for joining us and your participation.